A very good morning to all of you. I hope you all are fit and fine. Dear students, today we are going to start up with a new chapter. As you can see this image on your screens, I have taken four different pictures in which you can see everyone is moving. First of all, in the first picture, a person is moving. Can you see from one place to another? Yes, that is a person's motion. Right? In the second picture, a cyclist is moving. So I have written a bicycle's motion. In the third picture, a car is moving, where I have written a car's motion. And in the fourth picture, a train is moving, that is a train's motion. So you can see that in all these four pictures, one or another thing is moving, and when the things are moving, we use the word in science, that is the motion. Right? Now one more thing I want to add here is, when a thing moves, it moves with a particular time. It moves with a particular speed. Right? Suppose the train has to move. Okay, and you know that the train will move at a particular time and it will reach a particular destination in a particular time. Suppose we have to go to Delhi from Chandigarh, it will take 4 to 4.5 hours in your own personal car. Right? But if you move via a bus, via train, via aeroplane, then the particular time is given to you that this car, this train, this bus, this aeroplane will move at this schedule. Right? And it will reach at this time over there. So when a particular thing moves, whether it is a train, it is a car, it's an aeroplane, it's a bus, it's maybe a cyclist also, or you also. When you have to reach school, you have to reach school at before 8:15 a.m. You remember that? Yes. And the school is over at 1:30 p.m. And you have break also in between. You have periods also in between. So whenever some things moves, they move with some time and then the work moves on. So now you have understood that our today's chapter is chapter 13, motion and time. Motion means when the things move, and the things move with a particular time. Right? Let's move further. There are different types of motions. Right? And these motions, I have taken one picture here. These motions are of various types, but in our syllabus we will study only few motions. Right? Now first of all, let's come to the very first motion, that is the periodic motion. Can you see that there? Periodic motion? Yes. Now this periodic motion means the motion which occurs at regular intervals of time. This is the motion of the planets. Yes, the planets revolve around the sun. You can see that picture also. That's a periodic motion. I'm just giving you one line for each, because we will study only few in detail. Second one is rectilinear motion, the motion in which the object is moving on a straight line. Right? Then you have a curvilinear motion in which the object moves in a curve. You can see that. Suppose you throw a ball, you throw it with a great force, it goes up and then it comes down. So that is a curve followed. Then you have a translatory motion which starts at a particular time with some distance and it will finish at a particular point. Then you have circulatory motion in which the object moves in a circular motion. You can see that wheel over there. Then is the oscillatory motion. This is of a pendulum of a clock. You can see a string with a round bob. We call it as a bob, metallic ball in it. And you can see some faded movements of these bobs also. So when this 1 hour is over, it makes a sound of tung tung and then it moves like that. right? We will study this oscillatory motion in detail in this chapter only. Let's move further. Now, what is motion? If an object keeps on changing its position with time, it is said to be moving or in motion. Okay, when it is moving, but with respect to time, with respect to the changing of position, right? So now this motion can be of different types. Number one is linear motion, or we call it as straight motion, or I told you in the previous picture about the rectilinear motion. This is the motion in which the object travels in a straight line. The second one is the circular motion, when the object moves along a circular path, right? The third one is the curvilinear, in which the object moves along a curve. I showed you that picture and I gave you an example when you throw a ball. Okay, fine. Now this is what you can recognize. Without reading this fast motion and slow motion, you can recognize, because there was a story of the hare and the tortoise, and what happened at last? The tortoise win. So basically hare was able to run fast, yes, but because of his egoist things and because of he didn't take the actual real decision that what he should, whether he should take rest under the tree or he should move far further, what he thought, I will run faster, little later let me sleep for some time. You remember this story? So from this picture you can make out the motions are of different types, whether it is curvilinear, whether it is circular, whether it is rectilinear, whether it is periodic, oscillatory, but these are of two more types, that is slow and fast, right? Now what is this slow and fast motion? If one object covers a particular distance, right, in less time, and the other object covers the same distance in more time, now which one will move faster and which one will move slower? The one which is covering a distance in less time is moving faster, and the one which is covering same distance in more time, it is moving slower, right? Now this slow and fast motion is measured with the speed. Now what is the speed of an object? The distance travelled by an object in a unit time. Unit means in a particular time, we call it as a speed. You must have noticed there are speedometers in the cars, in the two-wheelers also, right? There you can find out whether you are moving with 60 km per hour, whether you are moving with 40 km per hour, or so on. We will study these things also in detail further. Let's move further. Now you can see this picture. We make a table like this, and where we take the distance covered by the hare and the tortoise in every 5 minutes. Can you see this? Now there is hare and here we have tortoise around a clock, right? Some people are watching here also. Can you see that? So I have divided this distance here in 5, 10, 15, 20, 25, 30 meter, 35 meter, 40 meter, 45 meter and 50 meter. So every distance is having a difference of 5 meters, right? And the hare and the tortoise, in every 5 minutes we have to see what are they are covering. So when we see that they cover, now you can see every is having 5 meter difference. So and the time is also what? 5 minutes. So when we see equal distance in equal intervals of time, that is the uniform motion. We will study it further. We have two types of motions, uniform and non-uniform. Now you will be wondering, earlier ma'am was saying curvilinear, periodic, oscillatory, then she said slow and fast, and now she has come to uniform and non-uniform. Dear children, basically that are the movements. The curvilinear is a movement, circular is a movement, oscillatory is a movement, okay, right? And then fast and slow is also there. But these fast and slow are there because of some reasons, and that is what we consider them under the category of motion, that is uniform and non-uniform. So basically motion is divided into uniform and non-uniform. Then we divide it into slow and fast, and then we have different types. But to make it easy, we take it along with the daily life example. So I started it with the easiest thing. So simple to complex we move. Okay. So now you can see the picture with the non-uniform motion in which there are many racing cars. Can you see? Boys must be loving this racing cars. So the girls also, it's not, but normally they have that taste. So these racing cars are pushing, they are moving across, crossing each other with a great speed. Now here the speed is different for every car, and the distance covered by each car is also different, right? Sometimes they have to apply brake. Normally they will not apply brake, we apply brake. So that is a non-uniform motion, that is a zigzag motion in which the body covers unequal distance in unequal intervals of time. So you don't know, you have given them only the starting position and the ending position, right? Then is the uniform motion. You can see the car is moving 2 meters in 2 seconds. 2 meters in 2 seconds means equal distance in equal intervals of time, right? Let's move further. Now this was I was talking about the distance. So they have speed also. Naturally an object is moving with some speed. So when the object travels a fixed distance with same time gaps is said to have uniform speed. So you have to move to the school with a speed of 60 kilometer per hour. Means in 1 hour you will only use 60 kilometers you will cover. So that is uniform speed. Non-uniform speed is when an object covers different distances in different time gaps, right? So when you, sometimes the race is at 80 kilometers per hour, sometimes it is 60, sometimes it is 40, maybe due to crowd. If the roads are overcrowded, then the speed is very slow. So that is non-uniform speed. The third one is the average speed. You must be aware with this word of average in mathematics also, right? Average means when we take out all the numbers. Okay, let's talk about your marks. You have scored 20, 30, 40, 50, these marks. So I have taken 20, 30, 40, 50, 4 subjects, right? So let's add these 20 plus 30 plus 40 plus 50 divided by 4. That is the average. We take out the average. Now this average is the total distance traveled by an object divided by the total time. Okay. I have covered 60 kilometer in 1 hour, 20 kilometer in 2 hours. So total distance is what? 60 plus 20 and the total time. We will study it further also in detail. You will see. Now here I have just make this, you can say it as a memory tip for you to learn these formulas. Now in this chapter you will be getting these numericals, a very simple calculation, but you have to learn these formulas. So I have made one memory kit with a colored diagram of a triangle shape. Suppose a question comes to you to find the speed, to find time or distance. So let's come to the first one. First triangle has DST. Now what is D? Distance. What is S? Speed. What is T? Time. Suppose I have to find the speed, right? So I have colored that part. So speed is what? Distance upon time. You can see this. Can you see this in math? So it means distance divided by time. In second one, in second triangle I want to find distance D. So D is equal to what? Now they are at equal level. So speed into time. In third triangle I want to find T, time. So this time is what? Distance upon speed. Can you see this? Upon means what? Divide. And the fourth formula is average speed. So what is average speed? Total distance divided by total time. So these all 4 formulas you have to learn them very carefully. Remember them, very easy, because they will help you to do the numericals. Let's move further. Okay, we are talking that we measure the speed, we measure the distance, we measure the time also. There are many events in nature that repeat after a time interval, like morning, the rising of sun. How do you come to know that there is morning? When the sun rises. Day and night, the time between the sunrise and the sunset, that is day, right? And the night is again the time between the sunset and the sunrise, that is night. Month, the time between 2 new moons. You must have heard full new moon, new moon. Yes, that is year. The time of the earth to complete its one revolution around the sun. When the time it completes its one revolution around the sun, that is the year. And 1 year has 365 days. Normally we say that, but it is 365 1 by 4 days. Okay, let's come further. We will study this. Time measuring devices we have. We use clocks. Clocks use the concept of periodic motion to measure the time. Now you remember why I use the word periodic motion? Clocks are used. Clocks are basically showing you the periodic motion. It means that it uses motion that repeats itself in equal amounts of time. And there are different devices, many devices. Number one is the sundial. You must have studied in history. Where is it? Basically, it uses its position of the sun to depict the time. It uses its position. In early, not early humans, it's like our ancestors. We can say our ancestors means maybe your grandfather's father must be aware how to find time. They use the concept of the shadows. How this tree has, okay, if this tree has this much of shadow, it must be afternoon. If this tree has this much of shadow, this is morning around 12 o'clock, around 2 o'clock. Still there are people in villages, those who find the time like this. Okay, so similarly is sundial. Another instrument we have is sand clock. You must have seen this sand clock in many pictures also, many movies. Hourglass we call it as. It uses sands to measure the time. Now you can see the sand is moving down. So this sand when moves down, it tells you the time, 1 hour or whatever it is. Okay, fine. Next you have a water clock. It uses water to measure the time. These all pictures are in your NCERT book, but I have elaborated a little more to them. Can you see this? Water is coming down. Then you have a pendulum clock, which we will study in detail. It's really very important. It goes till class 10 also. And if you will study in 11 and 12, then also you will study all these motions, sciences. Pendulum clock uses a pendulum to measure time. This is the string, and here you can see this round bob here. Can you see this round bob? That is, right? Then you have a quartz clock. Normally these were the ones which in these clocks, quartz is written there also. You can read this QUARTZ. Now they have an electric circuit that works with the help of cells, and they provide you the accurate time, right? Okay, let's move further. Let's come to the pendulum. I showed you the pendulum one clock. Now what is this pendulum? You can see this. This is the support. Okay. Now this is the support. How this support is there? Rigid support. Right? Now in this support you have a long thread. Can you see this thread? I have written thread, but there is a string. Then you have a circular one, metallic ball, which is known as bob. Right? Now this bob is attached to the support with some length. There is some length of this string. We call it as L. Right? And this bob is the metal ball. Right? And this thread I have taken as T, support as S, and metal bob as A. This is simple pendulum. Now when 1 hour will be completed, what will happen to the pendulum? See here. The pendulum is in the A position. When 1 hour will be there, then the pendulum starts striking on the two sides. So this center position is known as the mean position. Okay. And the two sides positions B and C are known as the extreme positions. So when 1 hour is there, when 1 hour is over, then the pendulum starts striking. So it will do ton and ton and ton. This ton sounds comes here. So from the mean position, it will move towards B. It will come back to its mean position. It will go to C. It will come back to its mean position. Right? Left, right, left, right, left, right. This is to and fro motion. This is the motion of a pendulum. Can you see? Can you understand? Okay. Again, I will repeat that the pendulum from the mean position, first of all, will go to the extreme position B. It will come back to the mean position. It will go back to the C extreme position. Again, it will come back to the mean position. So the vibration is there. That's why I was telling you, just see the fading images of the pendulum. Okay, let's move further. Very simple is this pendulum. Now in this, a simple pendulum contains a bob. Bob is the metallic ball, okay, or it is a metallic ball or a stone which is suspended from a rigid stand with the help of a thread. It's not only that pendulum one, you can make it, you just tie a stone with a thread, so the thread is your string and the stone is your bob, but don't hit anybody. And we call it as oscillatory motion. The to and fro motion means, the to and fro means from mean position to extreme position, okay. And the bob of the pendulum does moves from the center, that is the mean position of the pendulum, to its extreme position, and we call it as oscillation. Now what is oscillation? When bob moves from center mean position to the extreme ends, means it is one complete oscillation. I will show you how this oscillation is there. Now this oscillation is there like this. This is the mean position. 1, it is not 1, it is half. It will come back, it will go, and again it will come back, right? This is one complete oscillation. Again I repeat, from A it goes to B, come back to A, goes to C, come back to C. That is one complete oscillation. Is it clear? Okay. So next is, we have done this bob, we have done this oscillatory motion, we have done this oscillation. Now next is the time period. Now this time period of the pendulum is time taken by the pendulum of the bob to complete one oscillation. How much time it has taken? It can be 1 second, it can be 1 minute, it depends now, right? Next is, now we have done motion, we have done distance, we have done time, right? We have done speed. Now how we measure? There are some units. Okay, suppose mama goes to the market to buy a cloth for her suit. So what will she say? She'll say, give me 5 meters clothes. Or she'll say, give me 3 meters for the lower and 2 meters for the upper, right? When you take milk, what do you say? Give me 1 liter. So we use these units to measure. To have water, you take 1 liter, 2 liters. For the Coke bottles, 1.5 liters. Yes. So there are some units which are used for the measuring. Similarly, in time, the units of the times are second. The time unit of the time is second, minutes and hours, right? So second is S, minutes is MIN, and hours is H. To measure distance, we use meter and kilometers. Meters is M, kilometer is km. Now I'll tell you how you find the units of a particular term. Like suppose I have taken speed here. You know the formula of the speed is distance upon time. Now distance can be in meters also, I have written up, and time can be in seconds also. So you can write meter per second. Another one is distance can be in meters or minutes also. So you can write meters per minute. In third one you can write the distance can be in kilometers or hours. So you can write kilometer per hour. This is how we derive these units from the major, for the major terms, right? Next is you convert. This is really very important. Kindly see to it very carefully. Very easy also. If suppose I have told you convert meter per second and kilometer per hour, what is this? I am saying suppose that a car is moving with 60 kilometer per hour. Okay, and you convert it into meter per second. Or I will do vice versa. If I will say car is moving 60 meter per second, convert it into kilometer per hour. So how will you do this? You know that now kilometer per hour. Per means upon. Upon means divide. 1 kilometer upon 1 hour. Now 1 kilometer has how many meters? 1000 meters. I have written 1000 meters. And 1 hour I have written as it is. Now 1 hour has how many minutes? 60 minutes. I want in meters per second. Now 60 minutes has how many seconds? 3600. Means 1000 meter upon 3600 seconds. We know this. Or we can directly also write, I have detailed it, 1 kilometer has 1000 meters and 1 hour has 3600 seconds. This you all know. Now to find it in an easy manner, you just, in maths, we just cut these two zeros. Yes or no? If we will remove these two zeros, they will cut up and down in numerator and denominator. You will get 10 upon 36. This 10 upon 36 can be written as 1 upon 3.6. Right? This is the whole derivation which I have told you how to do. But dear students, a memory tip to you is, a very simple trick to you is, suppose you have to convert kilometer per hour to meter per second. This was how I have found 3.6. I have explained that. But I'll tell you a very simple thing. Suppose you have to convert kilometer per hour to meter per second. What will you do? You divide that value with 3.6. And vice versa, if you have to convert meter per second to kilometer per hour, what you have to do? Multiply it with 3.6. Right? Is it clear? Very easy. Again, I repeat, to convert kilometer per hour to meter per second is divide by 3.6. If you convert meter per second to kilometer per hour, multiply it with 3.6. I hope it is clear. Next is speedometer. You all know. It is a device which is used to measure the speed of the vehicles. And it is in kilometer per hour. And odometer is the device which is used to measure the distance travelled. Distance travel can be in meters or kilometers per hour. I have shown both the pictures. You can see it in your cars also, in your two-wheelers also. Both are there. Speedometer, speed measure, and odometer helps to measure the distance. Let's move further. Very easy. Distance time graph. This you have done in maths also. Very simple. Now a graph is which represents the distance of the object. So we call it as a distance time graph. Very easy. Now what is this? This is a graph paper. Okay, and you have to mark x-axis and y-axis. You know x-axis is horizontal. Can you see this? Y-axis is vertical. Can you see this? So on the graph, first of all, the first thing is you have to take the x-axis and the y-axis. So you will take this much piece. Now I will show you further. Now I have taken what? X-axis here, this horizontal, and y-axis as vertical. Now you have to take one scale. You have done it in mathematics. So for 1 kilometer you have taken 1 centimeter, and for 1 minute you have taken 1 centimeter. Now this is divided here as, can you see this, 1 centimeter in each? 1 centimeter in each. And here also it is divided. You can see this 1 centimeter below also in minutes also. 1, 2, 3, 4, 5. Each is having a difference of 1 centimeter. So we have divided this, right? So first of all, in the whole graph paper, we take 1/4 part. Then we have divided this into this. Now next is mark the values of times and distance in the graph. You have to mark the values. So I have marked the value 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now mark the set of the values of time taken and the distance in that time. Suppose I have covered 1 kilometer in 1 minute. So can you see this? 1 kilometer here. 1. Then 2 kilometers in 2 minutes. 3 kilometers in 3 minutes. 4 kilometers in 4 minutes. 5 kilometers in 5 minutes. What you have to do is, you can see here. Can you see this? I have joined all 1 kilometer, 1 minute. Then 2 kilometer, 2 minutes. 3 kilometer, 3 minutes. 4 kilometer, 4 minutes. Now these all kilometers and minutes are joined with the dotted lines. Now where these all are joining, I have drawn a straight line. Yes, this is a straight line. Right? So this shows this is a distance time graph. So when you get the straight line graph, we call it as a uniform motion. Is it easy? Again I repeat, you have taken one x-axis and then you have taken y-axis. Divided into equal scales, join each scale. 1, 1, 2, 2, 3, 3. I have taken 1, 2, 3, 4, 5. You can take anything. And whatever the graph you will get is this. But this straight line graph you will always get for your uniform motion. Straight line graphs. Now you can see here, this is the object has a uniform or constant speed. If the object is parallel to time axis, I will show the picture, that is stationary object. If it has a curve shape, it is a non-uniform. You can see this, and let's see this graph. Now you can see this uniform motion, straight line, right? If it is a parallel to time axis, that is object is at rest. If it is moving like a curve, that is non-uniform motion. Easy? So to find the distance, now this is a simple thing I have written. Speed is distance upon time. Suppose I have given this graph to you of distance versus time. I have shown you A and B. How will you find who is having more speed? The one A, which is more steeper, will have higher speed as compared to B. This is how we have done. With this chapter finishes, and let's revise it a little carefully again. Very easy chapter. Okay, and please learn the formulas also. We done the different types of motions, and we see these types of motions also. Then motion is when a object keep on changing its position. It can be linear, means on a straight line. Circular means along a circular path. Curvilinear means along a curve. Then you have fast and slow motion. Yes, and then you did the speed, distance traveled by an object in a unit time. Then you did uniform motion and non-uniform, means equal distance in equal intervals of time. Okay, uniform speed, object travels fixed distance in same time gaps. Non-uniform means different distance in different time gaps. Average means total distance upon total time. Then you did this formula. This memory tip is given to you. Learn this. Okay. Then measuring time, I gave you, we have different events in the nature, morning, day and night, month, year, and there are different devices also, like sundial uses the sun position, sand clock we use sand to measure time, water clock we use water to measure time, in pendulum we use pendulum, quartz, it's an electric circuit. With the help of cells, they gives you the accurate time. Then you did this pendulum, in which the pendulum is supported with a long thread and a bob is here, right? And this bob moves to the positions. The center one is the mean position, and these two are the extreme positions, right? And the one oscillation is covered when A moves to B, come back to A, goes to C, come back to C. This is one oscillation. Okay, and the time period taken to complete one oscillation is the time period, and this is the length of the pendulum. Can you see this, the height of the string? I have written here L also, right? Then we did all this. Then is the units. Time is measured in seconds, minutes, hours. Distance is meters and kilometers per hour. Suppose you have to find speed. If you forget, just divide these things. If it is meter or second, it is meter per second. If it is meter or minute, it is meters per minute. If it is kilometers an hour, then it is kilometers per hour. Now you can convert kilometer per hour into meter per second by 3.6 and meter per second into kilometer per hour by 3.6. So speedometer, you have to measure the speed, and odometer is to measure the distance traveled. Then distance time graph, very simple. Take 1/4. Horizontal is x-axis, vertical is y-axis. Take equal distances. 1 centimeter. 1 kilometer means 1 centimeter. 1 meter means 1 centimeter. So you have taken 1 square on each. Join the values. 1 meter, 1 kilometer. 2 meters, 2 kilometers. 3 meters, 3 kilometers. Like this. And then these lines should be the dotted one. Where these are meeting, just join that line with a straight line, and that is your uniform motion. Okay, this straight line. So straight line is a uniform motion. If it is parallel to the time axis, that is your object is at it. If it is not parallel, okay, it's showing a curve, that is the non-uniform motion. So if the steepers are there, the more is the steeper graph, the more is the speed. Thank you so much, children. With this, we have finished our chapter 13, motion and time. Along with this, I have given you a worksheet in which the numericals are there. I have tried my level best to give you the formulas in the videos, and I have explained that numericals in the worksheet. You can follow it, right? And if still you have some confusions, you just see the video again. You can stop, you can pause the video in between, you can go back and you can find out. And this is really very simple chapter. Thank you so much. Stay safe, stay healthy.